So remember, whenever you calculate a limit, your goal is to hopefully get to a point where you can plug in the value your variable is approaching and then get an expression that gives out a real number out of it. So that's what you want. Let's see if you can do that in this case. If you plug in minus k as w, so w is my variable, minus k is my constant. If you think about, like, usually, for example, if x was approaching 2, x is my variable, 2 is my number, my x value. And then in this case, then, if we use the same notation, w is my variable, k is my number. So how do I plug w equal to minus k to get hopefully a number out of this? Minus k squared plus 6k minus k. So whenever I see a w, I plug in a minus k, plus 5 minus k squared. And then the bottom is minus k squared plus k minus k. I'm starting already to see some problems. The top is k squared minus 6k squared plus 5k squared. Bottom is k squared minus k squared, and that's 0 over 0. So this is undefined. Right? As w gets closer and closer to minus k, the numerator gets smaller and smaller, but then the denominator also gets smaller and smaller. I can't tell which one is bigger. This is an indeterminate limit. Now I don't have to check this if I'm solving the problem, but just to illustrate, it's a good idea to at least check it out mentally in your mind, but you don't need to write that out every single time. But okay, how do I solve a problem like this? You have to somehow find a way to factor an expression out of the top and of the bottom so it can cancel out. And the expression you need to find is the expression that gives the 0 out. What's an expression that would give 0 out when you plug in minus k? So that would be w plus k. This is the problem. When you plug in w equal to minus k, this equal to 0. This is the problem. Even if I didn't know what the problem was, I could proceed. And from the bottom, it is easy to see that I can factor out a w to get w plus k. And that is the thing that I mentioned is the problem. And now the other alternatives that you'd have would to look at the top and see, can I factor out a w from the top? And I can't. There's not a w in here, right? So my other choice is so if I could factor a w, I could cancel this out, but that wouldn't help me. So I need to factor this guy out and cancel that. So this is how you do it. You look at this 6w and you see that this 6w is, so 6kw is 1kw plus 5kw. So this equals this. 1kw plus 5kw is 6kw plus 5k squared. So that's the limit when w approaches minus k. These two I can group, factor out a w out of them. I'll repeat the bottom. So factor a w out of the first two to get w plus k. And then the last two I can group as well. And then factor, what can I factor? 5k out of it. So you factor 5k out, careful so you don't get tired, w plus k. Right? When you pull out a 5k, there's a 5k here and a 5k here. There's one extra k that shows up. So now, right, I have w plus k in both terms, so I can factor that out instead. And that's my second to last step, because when I factor a w plus k out, I get a w from here and then a 5k. Finally, I can factor out or cancel out w plus k, in the limit when w goes to minus k of w plus 5k over w. That I'm able to plug things in. So plug in w equal to minus k, so that's minus k plus 5k over k. So 5k, you lose a k, you get 4k over k. Divide the k's, and the answer is the nice little number 4.